not have the all right, so this was the grade breakdown. So 4 people had 90 to 100, 2 people had 80 to an 89, 5 70 to a 79, 4 60 to a 69, 3 50 to a 59, 1 40 to a 49, and 2 0 to 9. So average was a 67, so a couple points below a 70. Highest grade was 100. I think there was a couple hundreds. But generally speaking, if you're in this cluster of people who did, 70% or better on the exam, you're probably fine. You know where you need to improve. Like I said, my policy is if you do better on the final exam than you did on the midterm, I'll replace your midterm exam with that. If you're in this next group, the 50% and higher, obviously you need some improvement, but I wouldn't say you're a lost cause at this point, especially with the policy of replacing your grade. You start getting down into 40 and below, then start asking yourself why did you miss so many points? If it was poor preparation or too much drinking the night before, well, if you can put some explanation to it, fine. But if you're getting a single digit in a midterm, then you probably need to rethink the class or something like that. So just from a strategic perspective, is there a great chance you're going to come back and do substantially better on the final exam? So in any case, I turned in midterm grades already, so you guys should be able to see those. They were due like last week, so they should have been out for a while now. That's if I was giving the grade today. I do curve at the end if it's necessary. So usually if you're on the bubble and you've shown that you've worked hard, you've done your homework assignments, things like that, I usually give you the benefit of the doubt. If you're somebody who has only turned in half the assignments or something like that, don't expect any sort of extra points from me, because you gave those up a while ago. So, in any case, if you want to discuss your grade at all, just let me know. I'm happy to discuss it with you. Okay. Yeah, so here's the lowest grade was a 3, highest grade was 100. Yeah, all over the place. So, let's go through this exam. And let's see, Keynote open here. Okay. Come up, get your test. Okay. Questions. Okay. So all programming languages have facilities for 3 ways of humans solve problems. What are those mapping? So 3 ways human beings solve problems. Let's just do, here's number 1. This is, here. Question 1. This is memory, asking questions, repetition. Memory is done through variables, that's the mapping. Asking questions is done through conditionals, if statements. Repetition is done through loops. You could have also said methods, something along those lines for question 1. Questions about that one? All right. Question 2, what changed between the C programming language and the C++ programming language? Why was this change necessary? So let's do 2. Well, we'll just answer it up here. Well, what changed? We had the addition of classes. So we could say this led to object-oriented programming. Why did we need this? Something along the lines of the types of problems we were solving were becoming more complex. And since the job of a programming language is to emulate the way we already solve problems, we needed an additional layer of, let's just say, organization to support our more complex solutions. Something in the ballpark of that. So there was plenty of reasonable explanations you could have given me, but something along the lines of our older languages held up pretty well for a long, long time, and then as our computers got more powerful and we started solving more complex problems, we started seeing weaknesses in those older languages and saw a necessity to start working with objects of things. So that's what the class let us do. It allowed us to organize our code inside of a little container so that we can work with it in terms of this container we're passing around rather than having all the wires spilled all over the place. Okay? Obviously, as our problems become more and more complex, the wires become scarier and scarier, right? Okay, if we're building a little tiny prototype for something that has 2 wires, not that big a deal. We don't really need to put that inside of a housing. But if we have something that has 600 wires and 9 batteries, probably want to hide the details from us because it becomes frightening. All right, questions on that one? All right, 3. What are the 8 Java primitive types and what kinds of values do each of them hold? As long as you got most of these and you, so kind of what was the goal of this question? A, do you know what a primitive type is? And then B, do you pretty much know most of them? Hopefully you guys see that if you forgot 1 or 2 of them, you still got the points. So as long as you were in the right realm of things. So question 3, it's byte. Well, here, let's just kind of group them together. Byte, short, int, long, and those guys are all built for holding whole sign numbers. Then we have char, so you could say characters. You could have also said whole unsigned numbers. That would also be accurate. We talked about chars holding 0 to 65,535. I was not looking for you to give me the range of those values. If you did, great, but I didn't check the accuracy. So if you flip to, no harm, no foul. So that's char. Then we have float, double, and these guys hold floating point numbers. Floating. And finally, Boolean. This is true / false, something like that. All right, so kind of incorrect things that I saw pretty often were like string. If you had all the rest of the stuff right, I maybe didn't take off points for string, but strings are not primitive types. They are actually object types. Java does sort of treat them in many ways as if they were primitives, but they are not officially primitives. The fact that you can call methods on them immediately disqualifies them as a primitive. Primitives can only hold a value. Okay? So, question 3. Questions on that one. All right, so now the hope was that most of these so far should have been relative gimmies. All right, so, or at the very least, if you missed points on these, you shouldn't have missed large swaths of points. 1 or 2 points here and there, but none of these 3 questions should have been overly difficult. This was just regurgitating knowledge, right? The programming ones, obviously, those are the ones that some of you did well on, some of you struggled on, and that's kind of par for the course right now. Okay? So, question number 4. What is a pointer? Do they exist in Java? Explain. Okay, pointers. Primitive types capable of holding a memory address? Okay, then the second part, do they exist in Java? Yes, but we do not have a specific syntax for dealing with them. Something along those lines. You know, we've seen that they exist. We've created arrays. We've tried to print out the array. We see a funky looking memory address. Clearly pointers exist in Java. We had some assignments where we passed something in, we made changes to it, and it had a global impact. So we were working with a memory address as opposed to a copy of a value, and that comes up in a later question as well. But Java doesn't give us specific syntaxes for working directly with those pointers. So they exist, but we don't really have access to the memory. All right, so I was fine with whatever answer you gave here, yes or no, as long as your explanation supported it. Okay? So if you said no because we don't have a way to actually work with them, that's fair enough. Okay, you could say pointers don't exist because, I mean, it's all for show, but if we can't do anything with the memory addresses, then that's a reasonable answer. So as long as your explanation supported what your answer was, that was fine with that. Question on that one. Okay, let's kick it to another slide before these values get too small. So that was number 4, so we're on number 5, right? A error-free Hello World program. So let's just jump into Eclipse real quick for this one, just to save us some time. All right, this is CPU stuff. Here, let's just create a new file real quick. No, actually, let's just create a new project for the midterm, since we're going to have some other code that we're going to be writing in here. Okay, so public class something, hello, driver, whatever, then public static void main string array args system.out.println hello world, something like that. Well, something pretty close to exactly like that. You could have shifted this guy around a little bit. You could have named this dude something different. The exclamation points were not required. In fact, if you said something completely different inside here, I was fine with it as long as you printed something to the screen. A couple of you took advantage of that spot and put some humor in there, and I appreciate that. Now, speaking of humor, some of you heard this from my other class. I almost got shot on Sunday. It was awesome. So I was golfing at Black Wolf Run golf course up in Kohler, like a really posh golf course. So we had a coupon thing that you can only use early in the season or late in the season. So we played it for $30, but it's like a $275 golf course. Well, apparently there's a hunting lodge right next door to this place. So the whole round, we're hearing gunshots leading up to this thing. And then we just assume, oh, it's duck season or something like that. And it's, you don't know how close gunshots are, right? Okay, so we get to the 8th tee, and I'm like, getting the driver out, getting ready to hit. The 8th tee sign explodes. Okay. So, you hear dogs barking or something like that. And we saw these hunters over there, in their orange jumpsuits or whatever it is that they're wearing. But and it's hard to say how far away they were because, we're like on an elevated tee, so maybe they were 100 yards away or 200 yards away or 80 yards away. I don't know. You could clearly see details on the dog, and they're not very big dogs. They were pretty close. So apparently, I guess the dog runs in and chases the bird up into the sky. That's how I don't hunt, but I think it was pretty clear that's how it worked, and that's how it worked in duck hunt, right? So in any case, the bird flies up in the sky. So I guess the hunters swing around and they do it, and then didn't realize they were aiming at golfers. I don't know if they hit the bird or not, but the sign next to us exploded. So it was, and the guy just waved like it was no big deal. He almost shot us. Now, in retrospect, being late in golf season, as long as I wasn't going to have any permanent long-term injuries, that would be a pretty good time to get shot. Because this was a really expensive course, so you sue them, they don't want bad press. This place, they host like major championships there, so a couple $1 million for taking a little bird shot, no big deal, right? But unfortunately, none of us got hit. All right, so that was the hello world question number 5. All right, so we should not have any questions on this one. Some of you were fortunate because usually I grade hello world as right or wrong, so either perfect or minus 10 points. Some of you only missed like 1 point on it if you missed something very small. So consider yourselves lucky. All right, 6. What is the difference between pass by value and pass by address? Pass by value sends a copy of the parameter into a method. And then you could maybe say something like changes are local only. Pass by address sends a pointer, or the memory address of the parameter, or a pointer to the parameter into a method. Changes are global. So anything you change changes the actual value in memory, not just locally inside the function. So that's pass by value versus pass by address. Okay, questions on that one? All right, question 7. How are class methods defined? How are they called? Class methods are defined using the static keyword. They are called using the name of the class in which they were defined. So when we see the definition of a class method, we'll see the static keyword out front. When we call a class method, we will see the name of the class in which the method was defined before the method name. So some of you said like class name dot method name, that's fine. As long as you kind of gave me some version of what's written there that I could follow, that's fine. Anything that started hovering anywhere near the instance method side of things was just all points gone. And this should have also been a gimme. I'm not sure how many times we said this in class, but it was at least 1,000. Probably not 1,000, but a lot. Very often. We often covered this. Okay. 8. What is the difference between index of and char at? Do I ask any more about that? From the string class. Okay, so question 8. Index of returns the position of a given character in the calling string, or a -1 if not found. Char at returns the character at a given position in the calling string. So index of versus char at. Make sense? All right, programming questions. Write a method called calcSide that takes in the length of 2 sides of a triangle and returns the length of the 3rd side. So I gave you the little formula, a squared plus b squared equals c squared, and then I told you about the square root method from the math class, whose method header follows. So it's a static method that returns a double called square root, takes a double as a parameter, and it is inside the math class. So that should have told you everything you needed to know in order to call this method. So we'll go ahead and we'll write the method down here. I didn't care if you made it a class method or an instance method when you were writing it. So static double calcSide. It's going to take a double A and a double B. and we're going to return math.square root of a times a plus b times b. Spacing, whatever you want, whatever makes you happy. Something like that. So a squared plus b squared, we're going to take the square root of that, return it. That should give us c. Make sense? All right, so that was calc side. So things I was looking for there, hopefully you can do algebra to some level, as long as you had everything else right. If you, didn't know how to do some relatively simple algebra, I didn't hit you too hard, but you should definitely know how to call the square root method. Okay, you definitely should know how to do that. You should definitely know how to write your method header. Like I said, I didn't care if it was static or not, but you should be able to write the return type, which should match the return type of square root. Name of the method, here's your parameters, that kind of stuff. So I was looking for some competence with writing a simple method. Okay, questions on that one? All right, last, write a class which represents a person. All persons have a height, weight, and name. Create an appropriate constructor for creating a person, as well as appropriate getters for its private fields. Okay, so for this you had to know what a class is, what a constructor is, and what are fields. And then also setters and getters, even though I said only getters that you had to write. So we're going to create a new class. We'll call this guy person. All right, and the information I said I wanted you to keep track of was height, weight, name. So we have a private variable height, and height we're going to say is in, let's just say inches. So this will be an int. And then private int weight, so we'll say pounds, and then private string name. So those are the three fields we're going to keep track of there. And then we need a constructor. Constructor should always have the same name. You can make it public, but it's not required, but they should always have the same name as the class. And we're going to take in three parameters for this. So string name, int weight, int height. This dot name is equal to name. This dot weight is equal to weight. This dot height is equal to height. So there's our constructor. So class person holds three fields, three pieces of information about a person. Here's a constructor for creating a person. And then since these are private, we're going to create getters for these three guys. So we're going to have a public int get height. This guy will return this dot height. Public int get weight. This guy will return this dot weight. And public string get name. This guy will return this dot name. All right, so that should be everything I asked for in number 10. So that's number 10. Questions about that one? Go ahead.
Would you end up with memory addresses, or would you end up with actual numbers?
Well, memory address is where? I mean, if I used, so this is just creating the person itself. So this is creating the blueprint for our person. If I wanted to then create persons out here, I can say person P is equal to new person, and this guy takes in what? The constructor says it takes in a name, a weight, and a height. So we're going to say name is Mike. Weight is $120, right? Sounds right? All right. Height, how many? I'm 6'5". How many inches is that? 60, 72, 77? 77 inches? All right. So there's the person, Mike. So if I were to do a system.out.println p, what would I end up with? What should display? These are the three pieces of information I passed in. They're going to get stored as these three fields right here. But my variable p is a class. It's an object. It's a pointer. So this is going to be a memory address. So there's the memory address for person. If I wanted to actually display these values, I would have had to write a display method or something like that. Did I ask you to do that? Constructor, appropriate getters for private fields. Yep, no display method. Okay, so if I want person to be able to show itself, you know, I could do a public void display and then say system.out.println this.name concatenated with, let's just put spaces between them, this.height concatenated with this.weight. So now I've given myself a display method that will actually show the stuff associated with a person. So system.out.println p shows me the memory address. p.display shows me the details about that person. Make sense? What could I have done to make this line print out the details instead of the memory address? I think we've talked about that already, right? So if I said that I wanted a line like this to no longer print out a memory address like this, but instead display something like this, what could I change inside of person?
Instead of calling it display, would you call it toString?
Well, you could, but so punchline is it does involve the toString method, but we need toString returns a string. And we would then return that guy. So we could still have display if we wanted to. Our display method right now prints something out. The toString method actually returns a string. Okay, but it has to be called toString. And what this guy did is this overrides the method we inherited from object. So we got a toString method from object, and that guy prints out that guy returns a string in this format. Okay, it looks like a memory addressy looking thing. If we decide to write our own version of that, now when we print out a person, it's going to call the more local copy of toString, which is going to show all this stuff. So if I run this exact same program again without changing anything out here, we'll see now we get the same information twice. Okay, and if I want the funky looking memory address thingy, I can come into the toString here and I can concatenate onto the end of this guy. We'll put just another space and then we'll say super.toString. So we'll go ahead and call upon the parent's version of that, which will then give us the memory addressy thingy. So there's the memory addressy thingy. Make sense? All right, so a couple things to keep in mind here. So first of all, nothing I did right there was very difficult. Every one of you in here should have been able to follow it when I wrote it. Okay, if you could not follow what I just wrote, then you got to think about your future in the course. Now, having said that, could you have written it yourself off the top of your head? Most of you, the answer should have probably been no. Not because it's difficult, but because you don't have enough reps in where it's gotten shoved into your head to the point that you can't forget it. Okay, I've been doing this for a few minutes. All right, so that's why we do so many homework assignments, and I want you to spend so much time on this outside of classes, because the only way you're going to be able to get to this where it can be second nature is by putting in those reps. So this goes back to what we talked about kind of first week of class is think about this programming as a skill set as being like a sport. Okay, it's like you're taking a bowling class. You're only going to get better at bowling if you go bowling. All right, you can't sit around and think about bowling and think you're going to get better at it. Okay, so that's why you really need to be spending time outside of class working on these things. You need to be, if you're really struggling with the homework assignments and you're not able to complete them on your own, then you need to be making an effort to get into a group. If you live off campus, I realize it's inconvenient, but hey, you either do better in your homework or you either show up on campus and work with a group and do better in your homework, or you just suffer the consequences, right? What are the consequences? Bad grade in the homework, and I didn't get the reps in, so I don't know how to do the stuff. So those are choices. So you decide which of those categories you want to be in. But punchline here is that hopefully this reinforces this idea that you need to be putting in the reps outside of class. When you see stuff in class, it should make sense to you. All right? It should almost always seem like, oh, I didn't think it was going to be that easy. Every now and then I'm going to write something, you're like, oh, that's just funky, that's weird, I don't really follow that, something like that. That's okay. If you are sometimes confused, par for the course, okay? But for the most part, when you see me write stuff in class, it should not look like Greek to you. All right, it should like, oh, okay, I understand that. I couldn't write it myself, but I understand what he just did. All right, as long as you have that connection, there's hope. Okay, if you're sitting in class and looking at the stuff and it just looks complete gibberish to you, get out now. Just change your major. Do yourself a favor. Just because you can't do this stuff doesn't mean you're stupid. This might mean you're not cut out for this. That's okay. So I'm not cut out for a whole bunch of stuff. Okay, so I was just thinking, I was looking at the midterm grades for some of my students, and a bunch of them were taking art classes, and I'm like, I wonder how badly I would do in an art class. Okay. But hopefully they don't grade too much. I'm very creative, but I'm not very good. So, well, you saw some of my paintings on Facebook. You're friends with me on Facebook. My wife took me to a painting class. It was called, wine in canvas. I went for the wine part. Yeah. So 2 bottles of wine, and it got the creative juices flowing. I had a ferret that was juggling fireballs. My paint. Oh, I have it in my office. It's a great piece of art. So I did not win the best painting award at the get together. So I was depressed by that. So I ordered another appetizer. Is what I did. Okay, so questions about the exam in general. Like I said, if you have specific questions about your test and how I graded something, come up after class and I'll go through it. And if I screwed you over, I'll give you points back. If I didn't, I'll tell you why and that kind of jazz. Okay, so let's go back to where we left off. I think we were in the middle of starting to practice with objects. We were creating some sort of Dungeons and Dragons-y thing, right? Cave crawler, here we are. Okay, so we have our driver. So what are we doing right now? We create a couple of rooms, cave entrance and a room 2. We gave these guys names. So, right off the bat, looking at just this line right here. If I go into the room class, what should I expect to find in there? Okay, so again, this kind of comes with connecting some dots for us. If I just show you this line of code right here, and you've never seen the room class before, but I'm telling you that line of code is accurate. From that one line of code, what can you tell me that you will find inside of the room class? When I opened up the room class, what is one thing you can tell me you will definitely find in there? I'm not asking you to guess. I'm asking you to translate that line. Ask yourself, what is happening on this line? I'm creating a variable, name cave entrance, of type room. So right off the bat, we know that there must be something called room, right? There's a variable, a class that we've written called room, if I've told you this line of code is accurate. And I'm setting this guy equal to a value. And the value is going to be this guy right here. It's going to be a memory address, right? It's going to be the value. How do we know this is going to be a memory address? What's the first sign that this guy is likely going to boil down to a memory address? Huh? The new keyword, this dude right here. New keyword, real estate agent always gives us memory addresses. Now, What always follows the new keyword? What kind of animal is that? Okay, something, it's going to be the memory address of the instance. So this whole thing here will return the memory address of the instance of room. But what's this guy specifically right here? What am I calling right there? Constructor. Okay, so I'm calling it a constructor. And what am I passing that constructor? What kind of animal is this guy? Cat, dog, string, int. It's a string. This is a string. Got the double quotes things around it, right? Okay, so I must have a constructor inside the room class that must take a string as a parameter. Now, I have no idea looking at this what it might do with that string if I'm just looking at this one line of code. But I know if I open up the room class, I expect to find a constructor in there. Specifically, I expect to find a constructor that takes a string as a parameter and nothing else, because I've told you this is a legal line of code and I'm only passing it one thing, a string. Now, what will the name of that constructor be in the room class? What do constructors look like in Java? Give me a fact about a constructor. Identical name to the class. So I should find something in there that looks kind of method-y, looks kind of like a method, but it should be called room. Same name as the class. Okay, anything else you can tell me about constructors? What will constructors never have? That other methods must have. It's the differentiating factor between a constructor and a method. Return type. Yep. Methods always have a return type. Might be void. We might advertise that we're not going to return anything. But methods always have a return type. Constructors never have a return type. Why? Why is that? Why would a constructor never have a return type? It's related to the fact that constructors always follow the new keyword. Go ahead. Okay, well, tell me what that means.
We're going to use it.
So it's related to this. Constructors always, 100% of the time, constructors follow the new keyword. So that's one fact to keep in mind right now. The other fact to keep in mind right now is constructors never return a value. So I'm asking you, why do they not return a value? What does the new keyword do? Remind me from 2 minutes ago. Memory address. New keyword will always give me a memory address. So if you were to put in a return type for a constructor, what would that return type be? Memory address. But unfortunately in Java, we don't have a syntax for directly working with memory addresses. So if it's always going to be a memory address, and we don't have a syntax for expressing memory addresses, constructors don't have a return type because it's always going to be a memory address. And we support that by always having it follow the new keyword. Okay, so that's the reason why memory addresses or constructors don't have return types. Constructors always return a memory address. And that's mechanically supported by them following the new keyword. In some other languages, we look at older languages like Objective-C, a constructor would actually have a return type. It would usually be a void pointer. Okay, and actually in Objective-C, it's called an ID, which is the more modern version of a void pointer from C. Okay, but C didn't have constructors because we didn't have objects in there. But punchline is that this is something that has kind of evolved out of our languages. Okay, so just by looking at this one line right here, we could figure out several things about what we expect to find in room. Now, what I want to impress on you right now is that's a really important skill for you to have. Okay, this isn't just trivia stuff, because you're not going to be able to hold the world's knowledge inside your head. You're going to have to be able to use documentation. Okay? You need to be able to look at other people's code. Okay? You know, I'm not an idiot. I know that when you guys are working your homework, sometimes you go out to Google, you look at somebody else's code, you copy it in, and that's fine. But you want to do more than just copy it, run it, and say, oh, it works. I'm done. Let's go drinking. Okay? You want to be able to read their code and find out why does that work. Okay, it's like, fine, I couldn't write it myself. I copied somebody else's. Now it works. Let's look at it and see if we can understand why it works. So that maybe next time I could write half of it myself. Okay, you know, let's set a goal up for getting better at this stuff. So when you look at code, you want to be able to make some conclusions about what you expect to find on the other side. All right, so if we look at this one line right here, what can we extract from that one line right there? In context of these three. So if you already know about this line here, what can you tell me about what must exist in other parts of my program based on what you see in that line? Okay, so we have something called add exit. And what is add exit? What kind of animal is that? How do you know it's not a constructor? Constructors always follow what? The new keyword. Okay, so do you see the new keyword here? Okay, probably not a constructor being called, right? Okay, no constructor involved there because we don't see the new keyword. So a couple things we might practice. Second, we see the new keyword, we should start looking for constructors. Expecting constructors. Don't see a new keyword, no constructors here. So that means we have an animal here that happens to have an open close parenthesis on it. So other than constructors, what kind of other animals do we know that have open close parentheses? Methods. All right, so we must have a method called add exit. All right, and what must that method take as parameters? How many things am I passing it there? What kind of variable? Look at room 2. Room 2 is of what type? It's a room. Okay, but good. I mean, you're good. You're good with that. So she said we're going to take in 2 things. Okay, that's just counting, people. That should be practiced by that. 2 things. 2. Okay, we got the little comma in the middle. So this is thing 1. This is thing 2. Okay. So thing 1, we look at this and we say, what kind of thing is that? That's a string. How do we know? Double quotes. Okay. This second guy, what's he? Well, we don't see double quotes. We don't see single quotes. So he must be a variable, she pointed out. Okay, so now we can ask ourselves, well, what kind of variable is it? Well, we go and look at room 2 here. Here's room 2, and we see that, oh, he's of type room. All right, so that means that if I go into whatever class that this lives in, I should find a method called add exit that takes in 2 parameters, a string and a room. Okay, is this a class method or an instance method? You've already told me it's a method. Now what kind of method is it? Okay. This entire class should be in like cadence right now, just saying that this is an instance method. Okay? At a glance, you should be able to tell this is an instance method. We're seeing the method being called. How do we call instance methods? We call them using an instance of the class in which they were defined. This guy is not one of our known class names, right? So if this is legal code, he must be an instance of something. Okay? Cave entrance, it's a variable right here. He's an instance of what? He's an instance of room. That means I should expect to find a method inside of room called add exit that takes a string and a room as a parameter. And should I expect to see static or should I expect not to see static? Should not expect to see static because it's an instance method. Okay? It's owned by instances of the class, not the class itself. Okay? So, a couple pieces of information I've distilled here. When I go into this room class, I should find a constructor named room that takes 1 string as a parameter. I should also find a method named add exit that takes 2 parameters, 1 a string and 1 a room. And this guy should return what? Look at the code. We're not guessing. Now, this one we can't with 100% certainty decide, because even if a method returns something, we are not required to use the value it's returned. Okay, but in this case, we clearly are not using the value. We're not storing the return value of addExit. We're not printing the return value of addExit. As far as we're concerned right here, addExit must not return anything, right? Because we're certainly not doing anything with it. We don't have something out front saying, int blah is equal to whatever this guy returns. If we had that, then we would assume that this guy must return an int. If we had string blah, that means this guy would return a string. That kind of stuff. But since we're not doing anything out here, at the very least, we should go in with a strong suspicion that addExit doesn't return anything. So if addExit doesn't return anything, what should I expect to find sitting in front of addExit when I go into the room class? What word? Because all methods require a return type. So if every method requires a return type, what will be the return type of addExit, which doesn't actually return a value? Void. It'll be void. All right, so let's see. So we just basically played computer programming Clue, right? So let's go into room and see if our predictions are accurate. Here's our constructor called room that takes a single string as a parameter. Here is our addExit. Where's addExit? Down here. Here's addExit. Returns void. We do not see static as expected. And this guy takes two parameters, a string and a room. Make sense? All right, so being able to connect the dots between where things are being defined and where things are being used is going to be very helpful for us. Okay, we were tested on that on the exam with that math.square root. Okay, I gave you the definition of a method. You should be able to call that method, even if you've never used it before, even if you don't even know what square root does. Okay, as long as you know you have to feed it this and it provides you this, at the very least you know how to call it. You might not know what to do with what it returns because you might not know what mathy thing it does, but if I throw it a double, it will give me a double for whatever reason. Okay? So, what does our code currently do? We create a couple of rooms. We link these rooms together with exits, and then we create a player, and the player has the name the follower. And then we go ahead and tell our player, we'll tell our cave entrance to add that player. All right, so everything that's happening in main is the creation of two rooms. So let's kind of draw a picture of this. I think we already did, but let's at least review that picture. Okay, so here's what we created so far. We have our cave entrance, we have our room. Those are the first two lines. So that's this part right here. Okay, those first two lines create those objects and they live somewhere in memory. Next, cave entrance dot add exit north to room 2. So what does this do? Let's just spread these guys out just a little bit here. So that just created a link between these two guys and labeled it north. That was the third line. This guy right here. Cave entrance, add exit to the north, and it should lead to room 2. Add exit to the north, leads to room 2. Next line says room 2, add exit to the south, leads to cave entrance. So now we start at room 2, we added an exit, and this one's called south. Now, we didn't have to use directions like that. We could have named this guy elephant. Okay, but that would kind of break our parsing on the other part where we're saying we accept directions north, south, east, west for traversing through our little cave. But in terms of calling our add exit, nothing keeps us from having something called elephant. So if I go ahead and run this, you have entered blah, blah, blah. So now I can type in I can type in north, and I think right now it takes us to that next room, right? Oh, was that what we were about to write? Okay, so we're about to write that. So if it took us into that next room and then we saw here, let's fix our elephant. We'll make the first guy elephant. So we'll be able to experience our, so there, possible exits, elephant. Okay, so didn't matter what string we passed in there, it's just taking in the name of the exit, the label, and then where it goes. Okay, so this is the picture we've drawn so far, except now this would be called elephant, but let's switch it back to north. Okay, so what does this screen do? These 4 lines build in computer memory this picture. That's what we have. We have 2 variables, cave entrance and room, each pointing to a room object, right? And as long as we didn't write toString inside of room, I don't remember if we did or not. Let's just check. Here, I'm going to show you a little trick here real quick. So I right-clicked and source. Isn't it here? I thought we have a thing called collapse all. It's pretty handy as our code gets bigger and bigger. Format. Maybe it's actually at this level. Can I right-click on this? Well, at the very least, there's this little thing you can kind of minimize the function. But there is a thing somewhere in here where I can say collapse all. I know it exists. I just am not finding it. I think it would be in refactor. Yeah, I don't know. I don't think it'll show up in here now, will it? Yeah, it exists somewhere in there. But it'll basically minimize all your methods so you can just look at method names more easily, not have all the code before it. But we'll just scroll through. No toString. So if I were to come out here, and let's just forget about player for a second, and I were to say system.out.println cave entrance, and then I were to say system.out.println room 2, what should display to the screen? 2 memory addresses, because we did not have a toString written in room. So cave entrance and room, these guys are both variables, but they are variables that point to rooms in memory. So I'll run this. We get our 2 memory addresses spit out to the screen here. There's our 2 room memory addresses. Okay, so useless to us right now, but at least we know that objects turn into memory addresses, and that jives with our idea of what the new keyword does. Okay, so we'll go and take that out. Now, what do we do next? Now we have this thing called a player. The player's name is the follower. All right, so we would expect inside the player class to find a constructor named player that takes in a single string as a parameter, right? That's what we'd expect to find inside the player class. And there it is. Here's the player class, here's the constructor, and here's a guy that takes in a single string. Okay. Back out here to driver. So now let's go draw that picture. So inside here, we now have a new dude. Let's change its color. Okay, this is the follower. All right. And he what do we call him? The player? Yep, the player. So we have a variable called the player, and that variable points to a player object whose name is the follower. Okay? So if I come out here and I print out player, what should display to the screen? Apply the identical logic that we applied 2 minutes ago. When I printed out cave entrance and room 2, it printed out a memory address, right? Why did it print out a memory address? Because they end up being pointers because the new keyword returned it, and specifically inside of room, we did not write a toString method. Okay? So that tells us that the systems.out.println class, well, this method, println, which lives inside of, it's an instance method of whatever class this guy is, which I think is a print writer, which lives in, which is a class field of the system class. When he takes an object in, he tries to call that object's toString method, and he knows that every object will have a toString method because every object gets it from object, right? So room did not write their own toString method, did player? Here's our constructor, set current room, display to user, show prompt. No toString in there, so when I print this out, I should see a memory address. There's our memory address for player. Okay? So we now have a variable called the player, a variable called cave entrance, a variable called room 2. Every single one of these is by definition a pointer. They are variables that hold memory addresses. We just proved it, right? Can't do anything with those memory addresses, but they are memory addresses. All right, so room 2 points to this room in memory, wherever it is. Cave entrance points to this room in memory, wherever that is. And the player points to this player in memory, wherever that is. All right, what's the last thing we do? We grab our cave entrance and we throw the player into it. All right, so a cave entrance is a room, and this guy has an add player method, add player, that takes a player as a parameter. And what does it do? It sets that player's current room to this, so that makes the player know what room they're in. So if you look at player here, one of the pieces of information a player keeps track of is his name, the input stream, the scanner that allows us as humans to talk through our player, okay, that lets our keyboard read stuff in. And then a player also remembers the current room that he's in. So 3 pieces of information that players remember. Their own name, what room they're currently in, and how they are linked to us human beings that are controlling the player. Okay? So inside room, when we add a player, very first thing we do is we tell that player to set his current room to us. So if I'm this room, in this case, the room is cave entrance. So cave entrance out here is a synonym for this in here, because we do not have access to the variable called cave entrance in there. So we're saying the player, the room you are currently in, is me. Okay, if I'm an instance of room, specifically the instance that's cave entrance. All right, then what are we doing? We're setting the room's the player equal to the player. So now here's some things that rooms are remembering. What does a room keep track of? Well, the room knows about its collection of exits. The room knows about the number of exits that are in that collection of exits, because we decided to go ahead and hard code our array of exits to 4. That there's a maximum of 4 exits in any room. North, south, east, west is kind of what we decided upon. And that each of those rooms will also, so that's the number of exits. A room supports exactly 1 name, and a room supports exactly 1 player. Eventually, we're going to want to have more than 1 player to be able to squeeze into a room. Otherwise, we wouldn't be able to create this scenario in here. Okay, it would just be me sitting here talking to myself. But right now, our rooms only support 1 player. Okay? So when we add a player to a room, we let that player know about the room he just entered. We then let ourselves know who our player is, and then we start writing some stuff out to the player. So we use that player to display to them, you have entered blah, possible exits are, then we go through all the exits inside of this room. So everything inside of the exits.length, we ask if there is actually an exit there, go ahead and display it to the user. Okay? And here's our function for add exit. How do we add exit? Well, we add it to the next available position, and then we increment number of exits. So realistically, we could have probably written this code here instead of going through the total length of exits, just go through cur number of exits. So we know exactly how many exits are in there right now. Okay, so instead of this guy, we could say this dot cur number of exits, and then we wouldn't need to ask the question, is it null? Because we know that cur number of exits is always equal to the number of exits that we've actually put into that bucket capable of holding 4 exits. So if we only have 2 things in there, we'll go from 0 to 1. If we have 3 things in there, we'll do 0, 1, 2. All right, so this guy is just a counter that tells us how many exits, and this guy changes whenever we add an exit. Okay. Then we go ahead and tell our player to show their prompt. Fine. What does that mean for a player? Right here, a player shows their prompt. So we print out the little prompty thing. Then we read in the user's response. And I think we proved last time. We do system.out.println user response. And this will print out whatever we typed in at the keyboard. So we're using that scanner input.nextLine. Remember the 3 things that a player keeps track of is their name, the way that we can talk to them, and the room they're in. So we're going to use that scanner to read in the string from the user. And then right now all we're going to do is spit it back out to the screen. All right, so we'll type in north, press enter, and it spits north out. That it read in north. Okay, so now the next thing, we put the comment here, the next thing we need to do is we need to process that player's command to move into that next room. Okay, or hopefully move into a room. So we've read in a string, specifically user response. Now in our case here, we typed in north, with the expectation that we would move into that room to the north because it was advertised to us that there is a room to the north, right? Okay, so the only room we know about as a player is the room we're currently standing in, okay? We know about our current room. So inside of current room, so I'm standing in this room and we're going to pretend like that door doesn't exist. We only have this one entrance back here, or one exit back here to the north. Okay, and that's room 2 out there. Okay, so what I can say is I need to communicate with my surroundings. This is object-oriented programming. We're living in like a giant Lego castle. Okay, so I'm in this room. So I'm an inhabitant of this room. I'm an instance of player, and this room is an instance of room. Specifically in our little world right here, we're in cave entrance. Okay, so my mechanism for getting through that exit is to yell to the room, "Cave entrance! Take me through exit to the north." All right, so it's going to be a little bit weird, but we're going to do it anyways. All right, so that's my only mechanism as a player right now, because all I know about as a player is how to talk to my current room and how to talk to the user who controls me and what my name is. That's it. Those are the 3 pieces of information that we know as a player. Far less than we all know as human beings, right? We're very limited what we've given ourselves access to here. All right, so we're going to yell to the room, "I want to go through an exit." So that means inside a room, we need to have an ability to take an exit. All right, so here's the exit that we're going to take. So we're going to pass in north here. And what are we going to do? We're going to loop through all of our exits. And if the exit matches the name we gave it, so as this current room starts flipping through his exits, right now there's only one, and he finds an exit whose name matches north, what is he going to do? He's going to go ahead and grab that exit, get the destination, which is the room that it connects to. So what does this tell us? If this is an exit, get destination must be an instance method that lives inside of our exit class. Here's our exit class. What does an exit remember? It remembers two pieces of information. An exit knows its name, and it knows the room that it leads to. Okay? And since these are private variables, get destination just returns to us the room that it leads to. So what's happening right here? If the current exit I'm looking at matches the exit I want to take. So in our case, cave entrance has one exit. That exit's name is north. I've said I want to take north, so we hit the jackpot the first time through this loop. Okay, then what am I going to do? I'm going to grab that exit. So the room. Okay, the room is who we're in right now. We're inside of room. The room's going to take that exit and he's going to say, "Give me your destination." All right, and his destination is going to be room 2, that area out there in the hall. All right, give me your destination. So that's what happens right here. Okay, so now we have room 2. What I have highlighted there boils down to what effectively is room 2. So the memory address of room 2. And then I'm saying, let's add a player to room 2. What player are we adding? We are adding the result of removing the player from this room. All right, so if I'm cave entrance right now, all right, I have an exit in one hand. Okay, I have the exit, now I can extract the destination of this exit. I also have the little peon that stands in this room over here. Okay, so I'm holding the follower. It's like, I'm going to remove you from this room and throw you through that destination. Okay, you are leaving this room and you're going to that room. Okay, the room is handling this. Be a little creepy if real life worked that way, but that's how it's working in our model right now, right? Okay, this is Legos, so we're making the room do all the moving. We ask the move to take us through the room to take us through that door, and then the room picks up the slack from there. Okay, figures out where we want to go, picks us up, removes us from this room, and puts us into the new room. All right, so remove player must be an instance method because we're calling it with this particular instance of room. So here's remove player, I'm guessing down here, nope, up here. Remove player, what does this guy do? He grabs the player we want to remove, then he sets the player variable for this particular room to null, and then he returns the player that we're returning. Okay, so now this guy is like in limbo. When I remove him from the room, he's no longer in any room for that exact moment. All right, so then what do? So I now have a player that's not in any room here. I'm going to add him to the destination room. What does the destination room say to do? Well, here's room 2. Add player to the room. We take that player in. We go ahead and set that room to this. We show the player, and then we set this room's player to the guy that just entered the room, and then we spit out to that player, you have entered blah, blah, blah. Okay? So what do we need to do down here in our room, or in our player? Last thing, no, we're out of time, is we'll say this dot current room dot take exit user response. So whatever we type in, we're going to pass it as if that's the exit. So we'll go ahead and run this. Possible exits are to the north. We'll type in north. It's going to go and find that exit. You have entered room number 2. Possible exits are to the south. If I type in south, it'll take that exit. Now we're back. So now we can jump back and forth between our 2 rooms. Make sense? All right. I will see everybody on Thursday and expect a homework assignment then.